There's just something really satisfying, isn't there, about keeping those old Tamiya RC cars running, the ones with the cool, detailed hard
Oh,
bodies.
yeah,
I mean,
absolutely.
the scratches and scrapes, they're like badges of honor from, some hard bashing. But actually restoring one of those rigid ABS bodies, that can be tricky.
It really can. And
Hmm.
a lot of the trouble, I think, comes from mixing up how you fix that hard ABS versus, say, the flexible polycarbonate or Lexan bodies. It's not the same thing at all.
Right.
So today, what we really want to dive into isn't just like slapping a patch on. It's how you can do a proper restoration, maybe even make it stronger than it was originally. Truly bash-proof it.
Okay, I like the sound of that. So let's unpack this first bit. Models like the Sand Scorcher, the Blackfoot, they use ABS. What exactly is that stuff? Why ABS for those?
Right, so ABS stands for Acrylonitrile Butadiene Styrene. Bit of a mouthful, but basically the acrylonitrile and styrene parts, they give it the stiffness, lets it hold all that great detail. But the B, the polybutadiene rubber, that's key. That gives it toughness, some impact resistance.
Oh, okay.
You can usually check the little ABS mark somewhere on the part. And understanding that mix is, well, it's crucial because it dictates the right way to repair it, especially for parts that take a beating. There's definitely a hierarchy.
A hierarchy, okay. So if we want the strongest possible repair, what's the top method?
Will
Gold standard.
chemical welding or solvent welding. You'll hear both terms. And the important thing here is this isn't glue. It's not an adhesive sticking two surfaces together.
Right.
It's a true fusion. You use a solvent that temporarily dissolves the surface layers of the plastic. The long polymer chains kind of untangle and mix across the joint.
Okay.
Then, as the solvent evaporates, they resolidify, lock together. You end up with one single, solid, monolithic piece of plastic again. Done right, you can get back 80, 90, even close to 100% of the original strength.
Wow, okay. So it literally becomes one piece again. That explains so much. Like why my old super glue repairs on my Blackfoot body always seem to crack right next to the glue joint.
Exactly.
Yeah.
That's the classic failure mode. Adhesives like CA glue or even epoxy sometimes, they cure into a hard, brittle patch, right?
Yeah.
But the ABS around it still wants to flex a little under impact. The rigid glue patch doesn't flex with it, so all the stress concentrates right at the edge of the glue and pop. New crack.
A stress riser.
Precisely. Glues are okay for maybe, sticking on a small non-structural detail part, but for a crack on a wheel arch or a split post, they're basically just setting up the next break.
That makes total sense now. Okay, so we need fusion, not adhesion. What materials then? What do we actually need in our Restorer's toolkit for this? Solvents first, I guess.
All right, solvents. The two main ones people use are acetone and MEK. That's methyl ethyl ketone. Acetone works, but it evaporates really fast, sometimes too fast. It can skin over the surface before it penetrates deep enough, potentially leaving voids underneath. Not ideal for maximum strength.
Ah, I see.
MEK, on the other hand, evaporates slower. That gives it more time to soak in, dissolve the surfaces more thoroughly, and let those polymer chains really mingle. It leads to a stronger, more ductile weld. It's generally what the pros prefer for a really solid integrated repair.
MEK. Got it. So what about reinforcing the area or filling gaps? I've seen people use like fiberglass mesh and shoe goo. Is that the way for ABS?
See, that's another common mix-up. Fiberglass mesh and flexible stuff like Shugo, that's the go-to for Lexan bodies, the clear, flexible ones.
Yeah.
Because Lexan is flexible.
Okay, right. Different animal.
Totally different. For rigid ABS, using flexible reinforcements and glues just doesn't work long-term, for the same reason CA fails. It doesn't match the properties. The ideal reinforcement for ABS is, well, more ABS, or styrene sheet, which is very chemically similar.
So use the same material.
Exactly. You cut a patch from ABS or styrene sheet, shape it, maybe use a little heat, and then you chemically weld that to the inside of the body using MEK. Perfect bond, same flex characteristics. Consistent.
And for filling seams or cracks cosmetically. Not just strength, but making it look good.
That's where you want something called ABS slurry, or sometimes sprue goo. It's basically homemade filler.
Homemade.
Yeah, you just take scrap pieces of ABS plastic, like leftover bits from a model kit sprue, hence the name, and dissolve them in your solvent, like MEK or acetone.
Yeah.
You let it sit, and it becomes this paste. Because it's made of ABS, it chemically welds itself into the repair area. It sands perfectly flush with the body. It doesn't shrink like typical Siller's can, so you avoid those annoying ghost lines showing up later under the paint.
Yeah.
It's just the best way for an invisible finish.
That's brilliant. So you can make it thicker or thinner.
Yep, you control the consistency. A thin mix, like juice, is great for pre-wetting surfaces before adding a patch or wicking into hairline cracks, a medium glue consistency for general bonding and filling, and a really thick paste or putty for bridging larger gaps.
Okay, so structural repair with ABS patches and MEK cosmetic filling with ADS slurry. Once all that's solid, how do you get that perfect, smooth finish for paint?
Patience, and an iterative process of sanding and priming.
Iterative.
Yeah, you do your filling and initial sanding, then you spray a light coat of primer. Primer is like your diagnostic tool. It's usually a flat, uniform color, and it will instantly show up any tiny imperfections, pinholes, scratches, or low spots you missed.
Ah, yeah.
So you spot fill those tiny flaws with a dab more ABS slurry, let it cure, sand it smooth again, then reprime that area. You might repeat this cycle a few times on problem spots until the primer coat looks absolutely flawless.
Gotcha. Sand, prime, reveal flaws, fill, sand, prime again.
Exactly. Then you're ready for paint. And crucially, for these hard ABS bodies, you want Tamiya TS spray paints. Those are lacquers formulated for hard plastics.
TS, not PS.
Never use PS polycarbonate spray on a hard body. It won't cure properly. It'll stay soft or sticky. PS is only for the inside of clear Lexan bodies. Matching old vintage colors can be tricky. Sometimes involves mixing custom ratios or using digital color matching tools, but stick to TS paints.
Right. Okay, this is fantastic for repairs, but you mentioned making them bash-proof. What's the secret for, like, ultimate durability, maybe even before it breaks?
Proactive reinforcement.
Okay.
Honestly, the best repair is the one you never have to do, right?
Makes sense.
So especially if you have a brand new, unpainted hard body,
Right.
or even one you've just stripped down. Look at the known weak spots, thin areas around wheel arches, sharp corners, those body mounting posts that always seem to snap.
Yeah, tell me about it.
Before you even paint it, you can dramatically increase its strength. Cut patches of thin ABS or styrene sheet. Maybe use a heat gun gently to form them to the curves on the inside of the body. Then bond them in place using ABS juice or MEK.
So, beefing it up from the inside out.
Exactly. It distributes impact loads over a wider area. It adds very little weight, but makes a huge difference in how well the body survives tumbles and crashes. Pre-reinforcing vulnerable spots is the single best thing you can do for longevity if you plan to actually run the car hard.
That's a game changer. So really, the big takeaway here seems to be this deep understanding of the material itself. Knowing its ABS, knowing how it behaves, and using methods and materials that create a true fusion, not just a surface bond.
That's it, exactly. When you match the material properties, when you aim for that monolithic fusion rather than just sticking something on top, you get repairs and reinforcements that are truly integrated, resilient, and, well, bash-proof.
It's a whole philosophy almost.
It is, in a way. And it makes you think, doesn't it? This whole principle of material consistency, understanding properties, aiming for fusion over simple adhesion, it works wonders for RC cars. But where else could we apply that? What other everyday objects, maybe even systems, could be made better, more durable, or easier to repair if we thought about them in this more monolithic way, something to mull over?